welcome to our video. I'm Alice.
And I'm Matt, and today we're going to be having a look at how maths applies to the real world, and as you can see by my whisk here, specifically to baking.
So let's get cracking.
So first up, we've got ratios. This is quite clearly obviously needed because we've got 8 to 9 making here, and we want to make probably 19 to 20, so we're going to look at probably potentially doubling all the values we've got here. I slightly added more.
So John, we've seen how we can use ratios in baking. Can you think of anything else in the real world?
Well actually, Matt, it's interesting you say that because I know a statistic that 1 in 10 people of the ages between 16 and 25 have chlamydia. So therefore, basing on a class of us, say 20 people, we have to assume that 2 of us will have chlamydia.
Thanks for that, John.
No worries.
On a slightly more serious note, ratios actually play a role in rocket science.
Next up, we've got conversion.
What, like Johnny Wilkinson in the Rugby World Cup final 2003?
No, Matt! Not at all!
So conversion is actually used in baking. So right now I'm converting 6 ounces of sugar into grams. And we know that 1 ounce is roughly 28 grams. So we just times that by 6 and we need about 168.
Conversion can also be used in the real world, like when exchanging money.
Hey lady, I'm going back to Alabama. Can I change this £20 UK sterling into some dollars?
Well, the conversion rate at the moment is about 1.5, so you can get 30 US dollars.
Perfect! Next up, measurement, and something I've wanted to measure for a very long time.
I thought you'd never ask!
No, John, not that! No, John, what I actually wanted to measure is flour, as Alice is doing so very well here.
And the key to measurement is just accuracy.
Measurement's also used in the fashion industry.
I'm just trying to measure John up for a dress that will fit.
Tessellation can be defined as the tiling of a plane using one or more geometric shapes, called tiles, with no overlaps and no gaps. John and Alice are trying to tessellate their biscuits. How are you getting on, guys?
Well, it's quite difficult because I think the shape might tessellate, but it's quite difficult to see if it does.
They also don't seem to be the exact same size, so it's a little bit tricky.
I don't think it does.
I don't think it does either.
Nice try, guys. Tessellation can be used in art, and particularly as we see here within Islamic art.
Tessellation is also found in nature, as you can see here in this bee's honeycomb.
Next up, timing.
So timing is obviously used in baking to make sure that your things aren't burnt, and looks like our cookies must be done.
Timing is also crucial in our everyday lives. John here needs to know what time to wake up so he can get to work on time.
I hate my life!
So this is our trial and improvement, and as you can see from these cookies, John needs a lot of improvement.
Trial and improvement can also be seen with Darwin's theory of evolution. This is Matt, he's my landscape gardener.
Well, love, we've got a decent area to work with here. I think we can fit a few more plant pots, and I'll get back to you later in the week. One thing I've always wanted to have a look at is the size of John's package.
I thought you'd never ask!
No, John, not that package! Your cupcake package!
Oh, okay, yeah.
So by John's package, what I actually meant was his cupcake package.
Well, as you referred to, Matthew, I have got a package where I can calculate the volume inside this particular package by doing the classic width times the height times the depth, and the dilemma I have today is how many of my cupcakes can I fit into this one particular box.
Packaging represents a multi-billion-dollar industry around the globe, with companies working tirelessly on the volume of their products to ensure high efficiency and low costs.
This is John. He's about to put his cupcake mixture into his cupcake cases, and the amount that he puts in will depend on the volume. So he's thinking about that very carefully as he puts that in.
Here is a classic example of when fractions are used in sports, showing quarterfinals, semi-finals and the finals and how they're split up accordingly. Here we've got a classic fraction dilemma here, where three of us want to share this one cupcake. How are we going to sort this?
Cupcake looks great, Alice, good baking, but how are we going to split it into three?
Well, luckily for you, I brought my protractor.
Ah, fantastic. Well, we know there's 360 degrees in a circle, so surely we split it into 3 lots of 120 degrees. What would that give us each?
A third.
A third!
A third! Voila!